Alright, hi. Today we're looking at the Locomotive chassis battery system. So this is the top deck of the Locomotive battery, the Locomotive frame. So what I did is I'm compressing the bottom locomotive, the bottom part of the frame, to the top part of the frame. And we're going to look at this in hidden line view so you can get the inner guts. Okay, in the center we have a circular type battery, which has a hole, portholes that run perpendicular and parallel, parallel with the long side, and then perpendicular at set points. And these are, so basically those are piping tubes that branch out for different, so the battery acid goes through this. There's a battery, and then the battery acid goes through the pipes into these little spikes where you can then run a wire or whatever you want to it. Let's look at the front side. Alright, this is what it looks like from the bottom. You have the battery port in the side. These are large discs, about the width of the frame. There's several discs in there. You see that there's a port going on the bottom. And then if you look any closer, we'll look at the trimetrics of that. We'll skip back to color fade. So now we're looking at the bottom of the frame. It's square. It has a lip, and we're gonna hide this face. So on below then it goes from the battery into a square, which has these battery chassis floats that compress. So we're hydraulically pressing battery acid to make resistance and voltage across the car frame body. And then let's see if I can't hide this some more. Alright, undo. Now we'll go from there to, so one level has, the bottom floor has the weight on it, and then above that you see bus extrude 1. So over here is the vent. Right here, that vents it out so it doesn't explode. You have these run the traction ties, traction motors, and others. So this main pipe runs battery acid when the float's on the bottom. Top bottom compresses the top. Now let's go to the notes. All right, this is the Locomotive frame chassis, and then Alright, the Locomotive chassis battery notes. It's a locomotive car frame. The battery is circular. The terminal ports are like a manhole terminal. The star cellular arrange or compressed. The compressed top shell frame on the pool of the bottom shell frame of battery acid. Battery similar to Chasiss or hearing aid battery. So circular patterns and fractals. You have positive, negative, positive, positive, negative, positive, negative, positive transistors. Battery acid flows through the grounding tubes. Battery flows from the tube like a hydraulic piston. Pressure ratio of negative and positive terminals to appliance. There's a P port. Top product decks the ground. The top of the deck needs to be grounded to the floor chassis. The battery stems both path tubing. So right there is the tubing from the battery that stems to the pathing. Consider ping. Pipes use steam and stems and angles. Battery sandwich floor pressure asserted on inserted on the battery acid. The battery fuses are like Christmas tree light bulbs and fuses. Battery system charge discharges in a dynamic brake resisting grid, charging the original battery system. Battery acid bleeds, performs capillary action, or traction motor switches tube dynamic can be to this battery floor system bleeds juice tube to series of parallel parts. With small sets of battery to appliance contacts, battery may flow contacts in delta waves. So actually, the battery is moving in flows, and I'm just call them delta waves. By separating battery pool, capillary, linear motion, like sinusoidal wave, check valves, knife switch, and valves online will positive, negative. You can close the valve, and then it would perform closing the circuit of a battery to make it into a battery cell on a butterfly side, negative positive contact, then closing the line positive to positive instead of negative to positive. So you can make battery links like kind of like switching a fuse in a light bulb on a Christmas tree. It will some of the lights will be in. This can be done in intermittent change, thus isolating the battery fluid between the switch valves, closing the bleed. They act as battery cells or power cells and pipe. Dynamic braking ground, battery cutout switch isolation of throttles during operation, charging main battery. Adam Nugent's brake pipe multiplier exerts air pressure system in the battery cavity, housing multiple hydraulic pressure. See drawing. Let's see if we can't bring that up here. Work pipe multiplier. We'll do a quick so. This is the brake pipe multiplier, main auxiliary brake pipe, and then when it comes back to this is multiple unit operations. This goes inside the battery and blows air to increase the hydraulic pressure for the pressure on the batteries, creating more resistance by having kind of like a cylinder, adding hydraulics air to a hydraulic cylinder, pressuring down, pushing into the tube's capillary. The 24RL is to apply hydraulic valve piston to the first lap and service and suppression. There would be an ammeter regulating valve, amplifier channels with watts, volts, hertz, amps, phase shifters, honing in frequency, an angle cock pop-out valve release, and then we'll go back to this. Switch one. So we're back, back to the drawing board. This is the front. This is the rear. Angle cop pop out. Releases multiple pressure wood glad hands, multiple main reservoir, brake pipe, auxiliary reservoir, capacitor rings, transducer gauges, AC EMF rectifier path to dynamic braking resistance grid type A retarder transistor flip-flop circuit for dynamic charging power battery ground chassis battery concrete slab flooring. And I have some notes in a notebook just to draw an electrical shaft. I guess I'll scan those in and I'll add a second video to this.